So students, let us solve some numericals on Fraunhofer's diffraction. Now in order to get through this numerical, you just need to remember a few formulas. What are they? The very first one is like distance of nth minima from central maxima, and what it is like xn equals to n lambda d by d. What if it's maxima? The distance of nth maxima from central maxima is xm equals to 2m plus 1 lambda d upon 2d. Now what if it's successive maximas or minimas except the central maxima? It would be x equals to lambda d upon d. Students, these were the formulas which we need to keep in our mind. Now let us go for the first numerical. In a single slit diffraction pattern, the distance between the first minimum on the right and the first minimum on the left is 5.2 mm. Then the screen on which the pattern is displayed is 80 cm away from the slit, and the wavelength of the light that is used is 5460 angstrom unit. You just need to calculate the slit width, which is not given in the question. So I would write down the given data, which is very simple, that capital D is 0.8 meter here. As it was 80 centimeter, I just converted it to meters. Then lambda is given as 5460 angstrom unit. I can convert it into meters by multiplying 10 to the power minus 10. Then I just want to focus on this very important data, that is the first minimum on the right and the first minimum on the left are separated by a distance 5.2 mm. Students, distances are always measured from central maxima. So the first minima on the right and the first minima on the left, these are two distances, that is x1 and x1, going for 2x1. So 2x1 can be written as 5.2 mm, which can be also written in terms of meters by multiplying 10 to the power minus 3. So this is what is given in the question. To find is pretty clear. Small d, slit width. The formula that would be used for this would be none other than for nth minima from central maxima, that's xn equals to n lambda d by d. So students, we are very clear and we just need to focus on the given data and the formula. So we would be taking this formula side and we would be saying that solution for first minima from central maxima is always given by substituting n equals to 1, then x1 equals to 1 lambda d by d. But we are not given with x1, we have been given with 2x1, so just multiply it on both sides. So multiplying by 2, we get 2x1 equals to 2 lambda d by d. And students, see here, we have already the value of 2x1. Why not just substitute it there? We also have value of lambda and value of capital D. So just substitute it one by one. Here is lambda and here is capital D as 0.8. Then the only thing left unknown is small d. On taking small d on LHS, you would be getting what is its value. So it's coming as d equals to 1.68 into 10 to the power minus 4 meter. That's it for this particular module. Now we would be moving ahead. In the next sum, we would see that particularly the diffraction pattern of a single slit of width 0.5 centimeter is formed by a lens of focal length 40 centimeter. For the very first time, something known as focal length is coming into picture. Calculate the distance between the first dark and the next bright band from the axis. It's given that the wavelength of light that is going to be used is 4890 angstrom unit. Students, focal length, right? We have learned that lens have focal length. So you just see at this diagram, here is a slit and exactly next to that is the convex lens, and on the screen you can see the pattern. What is F? F is the focal length here. And what is D? D is the distance between slit and screen. What we can observe is they both are approximately same, because slit and convex lens, they don't have much separation. So their focal length and capital D would be approximately same. So we would be considering it in our given data. We will be writing it like what is given first of all is the slit of width, that small d is 0.5 centimeter, which would be converted to meter. And then focal length would be nothing but capital D. It would be approximately equal to capital D. So the distance between screen and slit can be taken as 40 centimeter, which is nothing but 4 into 10 to the power minus 1 meter. Now you need to calculate the distance between first arc and the next bright band, but they have helped us by giving lambda as 4890 angstrom unit. So students, this is what is the given data we are already having. Let us go for what is to be found out, that is distance between the first arc and the next bright band. So we have the solution, we have the formula. Why not just substitute values there? So I would say that distance of the first arc and the next bright band is nothing but lambda d upon 2d, and it's like values are half into lambda stands for 489 into 10 to the power minus 9, capital D goes like 4 into 10 to the power minus 1, and small d is 5 into 10 to the minus 3. And by just substituting this, you would be getting the values as nothing but half into the whole part is simplified into just 978 by 5 into 10 to the power minus 7, and by simplifying this you would be getting it as 195.6 into 10 to the power minus 7. On further simplification, it would be 1.956 into 10 to the power minus 5 meters. So students, this was what asked in our question, and that's it for this particular module. Thank you.